This is SpaceTime, Series 19, Episode 74, for broadcast on the 21st of October 2016. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, Europe's Schiaparelli Mars lander lost on its final descent to the red planet's surface. NASA's Juno spacecraft suddenly enters an emergency safe mode. And more evidence for the existence of a ninth planet on the edge of our solar system. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Mission managers at the European Space Agency are still struggling to re-establish contact with the Schiaparelli Mars lander. The 577-kilogram spacecraft lost contact with ESA Mission Control in Darmstadt, Germany, during its 6-minute journey to the surface of the red planet. ESA's Director General Jan Warner says the agency doesn't know yet if the lander reached the Martian surface in one piece, a viewpoint backed up by ESA's Spacecraft Operations Manager Andrea Camazo.
I think it's very difficult to say a likelihood now. The problem is that to know there were some conditions under which the lander should have landed, and this we judge it as soft. Unfortunately, we are not in a position yet, but we will be, to determine the dynamic condition at which the lander has touched the ground, and then we know whether it could have survived structurally or not. We are not in a position to say this now because we don't have any data. So we are still processing the data of the descent. From the surface, we have no data at all. The TGO is not planned at all to listen to DDM. It's an on-orbit where it cannot perform this action anymore. Could perform it during the descent, but that was it. This is absolutely nominal. So the TGO cannot hear anything from the EDM. We had 2 additional overflights of MRO, during which no RF signal has been recorded at all. So it's not that the data are confused, there's no RF signal. So definitely we have no evidence. We will keep monitoring. The EDM is meant to do a session in so-called open loop. So transmits again a radio signal, which Mars Express and the Pune radio telescope might pick up. So this we are listening in. MRO later performs another overflight, we'll listen in. So we keep monitoring from the EDM. If there is a signal coming, we would pick it up for sure.
Orbital images of the landing zone show what appears to be a crash site and evidence of an explosion. Analysts say the Schiaparelli probe appears to have fallen up to 4 kilometers before slamming hard onto the Martian ground. Earlier, Schiaparelli had successfully separated from the ExoMars Trace Gas Orbiter mothership as programmed on the 17th. While the ExoMars Trace Gas Orbiter successfully conducted an engine burn to achieve Mars orbit insertion, the Schiaparelli lander cruised to an altitude of 120 kilometers above the red planet's surface and then began its EDL, or Atmospheric Entry, Descent and Landing phase. The cone-shaped probe entered the Martian atmosphere as planned on the 19th, using a combination of heat shields, supersonic parachutes and rocket thrusters to slow down from 21,000 kilometers per hour to just 4 kilometers per hour for what should have been a soft landing, in the process testing new technologies to be used on a future European Mars rover mission slated for 2020. ExoMars was launched in March as a joint European Space Agency and Russian Federal Space Agency mission with the primary goal of studying the Martian atmosphere. Mission managers lost contact with Schiaparelli just moments before it was due to touch down on the Meridiani Planum. NASA's Deep Space Communications Network's Madrid tracking station had just taken over from the Canberra tracking station about 50 minutes before the expected touchdown. Everything was going as planned when, just a minute before the anticipated touchdown, at an altitude of less than a kilometre, all contact was suddenly lost. The timing matches to a point in the descent phase when Schiaparelli's parachutes were to be jettisoned and its 9 CHT-400 hydrazine thrusters were to be ignited to further slow down and stabilise the lander. At this stage, it's not known if the parachutes or the thrusters malfunctioned. Mission managers have confirmed that the entry and descent stages of the flight were occurring as expected. However, it seems events began to fall apart following the ejection of the heat shield and the parachute. The ejection itself appears to have occurred earlier than expected, and although ESA were able to confirm that the thrusters were briefly activated, it seems they may well have switched off earlier than expected, forcing the lander to fall to the ground. NASA's Mars Opportunity rover, which is also exploring the Meridiani Planum region, had its cameras pointed towards Schiaparelli's flight path for the lander's descent. Its observations, together with all the available telemetry from Schiaparelli and data from other NASA and ESA orbiting spacecraft, are now being carefully sifted through to try and determine exactly what happened. For ESA, this is the latest in a string of lander failures. In November 2014, the comet-chasing Rosetta spacecraft's Philae lander failed to touch down as planned on the surface of the comet 67P Churyumov-Gerasimenko, instead bouncing across the surface and ending up on its side in a dark ditch. And ESA's first attempt to land on Mars, way back in December 2003, also ended in failure. The Beagle 2 spacecraft, which had flown to Mars aboard the Mars Express orbiter, suddenly lost contact during its descent to the red planet's surface. In January 2015, NASA's Mars Reconnaissance Orbiter spacecraft finally spotted the Beagle 2 intact and safely on the surface at its Ascidius Planeta landing site. However, it also found that 2 of the lander's 4 solar panels had failed to deploy and were blocking the spacecraft's communications antenna. Meanwhile, the primary mission being undertaken by the ExoMars Trace Gas Orbiter is continuing smoothly. The probe is studying the Martian atmosphere, looking for, among other things, traces of methane. Methane's been detected by both spacecraft at Mars and also Earth-based observatories, raising considerable speculation and excitement among astrobiologists. You see, although methane can be produced through geological activity, its most common source here on Earth involves biological processes. Now, while scientists aren't expecting to find Martian cows, the methane they're seeing could be a byproduct of subsurface bacteria, archaea, or other extremophile microbes, and therefore could herald the historic first ever evidence of life beyond Earth. Sticking with spacecraft problems, and NASA's Juno spacecraft, which is exploring Jupiter, suddenly entered safe mode on Tuesday. Early indications are a software performance monitor induced a reboot of the spacecraft's onboard computer systems. Mission managers at NASA's Jet Propulsion Laboratory in Pasadena, California, say the spacecraft acted as expected during the transition to safe mode. It then restarted successfully and is now healthy. They say high-rate data is now being restored and the spacecraft is continuing flight software diagnostics. However, all the science instruments were offline, and so the planned science data collection from the mission's second close flyby of the Jovian cloud tops didn't occur. At the time safe mode was entered, the spacecraft was more than 13 hours from its closest approach to Jupiter, and so it was still well clear of the gas giant's more intense radiation belts and magnetic fields. Juno is designed to enter safe mode if its onboard computer perceives conditions that are not as expected. In this case, the safe mode turned off instruments and a few non-critical spacecraft components and confirmed that the spacecraft was pointing towards the sun to ensure the solar arrays were receiving power. Meanwhile, back on the ground, mission managers are continuing to study an unrelated issue with the performance of a pair of valves which are part of the spacecraft's propulsion system. Last week, the decision was made to postpone a burn of the spacecraft's main engine that would have reduced Juno's orbital period from 53.4 to just 14 days. The next close flyby of the Jovian cloud tops is slated for December the 11th, hopefully with all science instruments working. Meanwhile, the Juno science team are continuing to analyse the data coming back from the first close flyby back on August the 27th, when the spacecraft soared down to 4,100 kilometres above the planet's obscuring cloud tops. Revelations from that flyby indicate Jupiter's magnetic fields and aurorae are far bigger and more powerful than originally thought. Juno's microwave radiometer instrument also provided data giving mission scientists their first glimpse below the swirling cloud deck of the solar system's largest planet. The radiometer can peer down to about 400 kilometres, allowing scientists to see atmospheric structures and processes going on deep below the visible Jovian cloud tops. The Juno spacecraft was launched back on August 5, 2011 from the Cape Canaveral Air Force Base in Florida, arriving at Jupiter on July 4th this year. Juno's year-long mission around Jupiter will allow scientists to improve our understanding of Jupiter's formation and evolution. The spacecraft will study the planet's origins, its interior structure, deep atmosphere, aurorae, and magnetosphere. In the process, Juno will help us understand the history of our solar system and provide new insights into how planetary systems form and develop. Juno's highly elongated and elliptical polar orbit allows it to repeatedly dive between the planet and its intense radiation belts of charged particles, travelling from pole to pole in just an hour. By the way, Juno's name comes from Roman mythology. The mythical god Jupiter drew a veil of clouds around himself in order to hide his mischief. But the goddess Juno was able to peer through the clouds and reveal Jupiter's true nature. The yet-to-be-discovered planet 9, which may lurk beyond Neptune on the outer rim of our solar system, could help scientists explain the mysterious 6-degree difference between the Sun's equator and the average orbital plane of the planets. The findings, reported in the Astrophysical Journal and on the pre-press physics website archive.org, provides the first compelling evidence to explain the unusual wobble of the planets with respect to the Sun's equator. Science's current understanding of planetary formation involves the collapse of a cloud of cold molecular gas and dust, forming a spinning sun in the centre, surrounded by a spinning disk of material which eventually condenses and accretes to form the Earth and other planets. This protoplanetary disk should be revolving on a plane extending out from the Sun's equator. However, in our solar system, that's not the case. Instead, there's a 6-degree difference, which the existence of a 9th planet might well explain. The idea of a 9th planet, much larger than the Earth and tilted on a highly elongated orbit in the Kuiper belt out beyond Neptune, was hypothesized by Caltech's Konstantin Batygin and Mike Brown in January to explain the unusual orbits of several small Kuiper belt objects. The Kuiper belt is a vast region of frozen worlds, comets and icy debris, circling the Sun beyond the orbit of Neptune. Brown and Batygin concluded that Planet 9 is about 10 times the size of the Earth and circles the Sun about 20 times further out than Neptune's orbit. Planet 9, based on these calculations, appears to orbit at about 30 degrees off from the other planet's orbital plane, in the process influencing the orbits of a large number of objects in the Kuiper belt, which is how Brown and Batygin first came to suspect this planet existed. Of course, the irony of the Planet 9 hypothesis is that Mike Brown's discovery of the dwarf planet Ares led to the demotion of Pluto from its former position as the solar system's 9th planet to the new, apparently lesser category of a dwarf planet. The lead author of the new study, Caltech's Elizabeth Bailey, says because Planet 9 is so massive and has an orbit tilted compared to the other planets, the solar system has no choice but to slowly twist out of alignment. Put simply, Planet 9's angular momentum is having an outsized impact on the solar system based on its location and size. You see, a planet's angular momentum equals the mass of an object multiplied by its distance from the Sun, and it corresponds with the force that planet exerts on the overall system's spin. Because the other planets in our solar system all exist within just a few degrees of each other along a flat plane, their angular momentum works to keep the whole disk spinning smoothly. Planet 9's unusual orbit, however, adds to a multi-billion-year wobble of that system. And mathematically, given the hypothesized size and distance of Planet 9, a 6-degree tilt fits perfectly. The next question then is, how did Planet 9 achieve its unusual orbit? Though that remains yet to be determined, Planet 9 could well have been ejected from the neighbourhood of the gas giants by Jupiter and Saturn as they migrated out to their current orbital locations. You see, some calculations showed that there should have been at least 3 ice giants forming beyond Saturn. And as Jupiter and Saturn migrated out, they caused Neptune and Uranus to swap positions, in the process ejecting a third planet either to the outer edge of our solar system or beyond that into interstellar space. Another possibility is that Planet 9 was captured by the Sun's gravitational pull from another star system. Or alternatively, it was dragged into its current tilted orbit by the gravitational pull of other stellar bodies in the solar system's distant past. For now, all astronomers can do is continue searching the night sky for signs of Planet 9 along the path they first predicted back in January. Mind you, that search could take 3 years or more. Meanwhile, Astronomers from the University of Arizona have provided additional support for Planet 9's existence and also narrowed the range of its parameters and location. The team, led by Renu Malhotra, found that the 4 Kuiper Belt objects with the longest known orbital periods all revolve around the Sun in patterns most readily explained by the presence of a distant planet with about 10 times the mass of the Earth. Malhotra's calculations also show Planet 9 should complete an orbit around the Sun roughly every 17,000 Earth years. Its apogee, or furthest orbital position from the Sun, would place it over 660 astronomical units out from our local star. An astronomical unit is about 150 million kilometres, the average distance between the Earth and the Sun. Scientists think most objects in the Kuiper Belt dance mainly to the tune of the giant planets, Jupiter, Saturn, Uranus and Neptune, influenced by their gravity, either directly or indirectly. However, there are some known Kuiper Belt objects that are simply unlikely to be significantly perturbed by the known giant planets in their current orbits. These extreme Kuiper Belt objects, as they're called, all have extremely large orbital eccentricities, which bring them relatively close to the Sun at one point in their orbital journey, only to swing far out into interstellar space at another point in their long elliptical orbits. When the team analysed data from these most distant Kuiper Belt objects, they found something strange. It suggested that these distant worlds were all in some kind of resonances with an unseen planet. The peculiarities of the orbits of these extreme Kuiper Belt objects had simply gone unnoticed until now. The team found that the orbital period ratios of these objects are close to the ratios of small whole numbers. A hypothetical example would be a single Kuiper Belt object travelling around the Sun once, while another takes twice as long, or 3 times as long, or even 4 times as long, and so on, but not, say, something like 2.7 or 4.3 times as long. These sort of ratios arise most naturally if the extreme Kuiper Belt objects' orbital periods are all in small whole number ratios with a massive planet which would help stabilise their highly elliptical orbits. The findings bolster previous work that showed 6 of these objects travel on highly eccentric orbits whose long axes all point in the same direction. This clustering of orbital parameters of the most distant Kuiper Belt objects suggests a large planetary-sized body shepherding their orbits. The new study provides more specific estimates for the mass and orbit that this planet would have, and more importantly, constraints on its current position within its orbit. In other words, it gives scientists an idea of where to look. The team's calculations suggest 2 likely orbital planes for the planet. One is moderately close to the orbital plane for the solar system as a whole, and close to the average orbital plane for the 4 extreme Kuiper Belt objects at about 18 degrees. Meanwhile, the other's a far steeper orbital plane, inclined to about 48 degrees. While the new findings provide additional support for the idea of potential Planet 9 and lay out possible orbital scenarios, it's still not definitive proof of the planet's existence. For one thing, the very far and faint Kuiper Belt objects haven't been observed for very long, and given their minuscule apparent motion along their immensely long orbital journeys around the Sun, the estimates for their closeness to whole number ratios for orbital periods comes with heaps of uncertainties that can really only be narrowed down through more observations. The long orbital timescales in this region of the outer solar system could also allow formerly unstable orbits to persist for very long timescales, possibly even as old as the 4.6 billion year age of the solar system, without the help of any orbital resonances. In this scenario, orbits whose orderly parameters appear as testimony to the stabilising influence of an unseen Planet 9 may in fact be in the process of deterioration, but simply haven't been observed long enough for it to show. Again, it's a case of needing further observations and studies into the dynamical lifetimes of non-resonant planet-crossing orbits in far regions of the outer solar system. A Russian Soyuz FG rocket has successfully launched into space from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan, carrying 3 new Expedition 49 crew members to the International Space Station.
So the first umbilical tower is separating. We heard the ground propellant feed's been terminated. The Soyuz now on internal power.
Launch command issued for ignition. Second umbilical tower separate.
The second umbilical tower has retracted. The engine's firing now, going up to flight speed and liftoff. Shane Kimbrough, Sergei Ryzhikov, and Andrei Borisenko blasting off from Kazakhstan, making their way towards the International Space Station. good calls from the teams out in Baikonur. Everything looking nominal or normal throughout the flight so far. The first stage of the Soyuz delivering 930,000 pounds of thrust from those 4 strap-on boosters and single-core engine, which are now rocketing over the Kazakh steppe. The first stage, measuring 68 feet in length and 24 feet in diameter, is going to be burning that liquid fuel for the first 2 minutes and 6 seconds. Velocity of the craft now over 1,100 miles per hour. The next major milestone will be the jettison of the escape tower, that coming at about 114 seconds. The Soyuz spacecraft already well in excess of 1,000 miles an hour, rocketing towards space, continuing to get good performance calls from the ground engineers in the launch bunker. All of the different parameters on the Soyuz rocket continuing to look nominal or normal.
First stage separation.
And so the first stage, those 4 strap-on boosters at this point have been jettisoned, completing their job and dropping away. The Soyuz already at an altitude of about 28 statute miles, traveling in excess of 3,350 miles per hour. Again, the core stage, or the second stage, is going to continue to burn. Getting confirmation the launch shroud has been jettisoned, that protective shroud around the Soyuz spacecraft.
Launch shroud.
So the Soyuz now exposed. The second stage continuing to fire.
Second stage thruster is operating nominally, and the crew is feeling good.
Everything looking good with the second stage. Soyuz now traveling at a speed of about 4,700 miles per hour. And the core stage performing as expected. It's 56 feet in length, 13.5 feet in diameter. That single engine with 4 fuel chambers, providing between 178,000 and 222,000 pounds of thrust, depending on where they're at in the Earth's atmosphere. Second stage going to continue to burn until the 4-minute, 43-second mark. At that point, they're going to do what's known as a hot stage, where the third stage will ignite while the second's still burning. This is why the Soyuz has that small open grating area in between the second and the third stage. Just past 4 minutes into the flight now, continuing to get good calls, everything looking normal with this ascent. Again, the whole process today going to take about 8 minutes, 45 seconds from that liftoff until the Soyuz is in its initial orbit.
YPR nominal, and everything nominal on board, and the crew is feeling good.
And standing by shortly for the ignition of the third stage and the jettison of the second. And with that, the third stage ignition confirmed. The core booster now separated in an altitude of over 105 statute miles. So that third stage single engine now providing 67,000 pounds of thrust, burning for 4 minutes and 2 seconds, is going to deliver the Soyuz into its initial orbit.
The crew is feeling good. 330 seconds, and third stage thruster is operating nominally. Everything nominal on board. Copy. 350 seconds, nominal flight. Everything nominal.
And it's already been over 6.5 minutes since liftoff, which happened right on time at 3:05 a.m. Central Time, 2:05 p.m. over in Baikonur, now powered by that single third stage engine. This is going to continue to burn until about the 8-minute 45-second mark, so about 1 minute and 40 seconds from now. And then once the third stage delivers the Soyuz into its initial orbit, the module separates. It'll execute all of those pre-programmed commands to prepare it for all of its on-orbit operations, extending the solar arrays and all of the necessary navigation and communication antennas.
We copy. All parameters are normal. And the crew is feeling good. Thruster operation stable.
Seeing the telltale jolt and getting confirmation the third stage has separated, Soyuz now flying free. Already getting confirmation the solar arrays have deployed, sounding like the navigation antennas as well. Getting confirmation from the visiting vehicle officer here in Houston, the solar arrays and all antennas now deployed. Soyuz ready for on-orbit operation.
The Roscosmos Soyuz MSO-2 capsule docked with the space station's Russian Poisk module 2 days later, allowing the team to join the existing 3 Expedition 49 crew members on station for an expected 4-month stay on the orbiting outpost. It'll be a busy time for the crew, with more than 250 experiments to be conducted covering biology, earth sciences, human research, physical sciences and technology development. The crew are also expected to welcome no fewer than 5 resupply spacecraft during their stay. The first will be on Sunday when the first orbital ATK Cygnus cargo ship arrives, carrying over 2.3 tonnes of science and research equipment, as well as crew supplies and hardware. The Cygnus flight launched last Monday on Orbital's newly redesigned Antares rocket from NASA's Wallops Island Flight Facility on the Virginia Atlantic coast.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Cygnus lifting off on top of its Antares rocket on its mission to deliver supplies and science to the International Space Station.
The flight was the first Cygnus Antares launch since Orbital's October 2014 disaster, which saw an Antares rocket crash back to Earth just 15 seconds into the mission. The failure was eventually traced back to a faulty turbo pump on one of the main stage's two Russian AJ-26 motors. The AJ-26 motors were refurbished NK-33 engines originally built in the early 1970s by the Soviet Union. Monday's launch was the first to use two of the new RD-181 rocket engines. The RD-181 is based on the Russian Angara RD-191 engine, originally developed as a single-chamber version of the RD-170 motors used on Russia's Zenit and Energia rockets, and the twin-chambered RD-180 used on the United Launch Alliance's Atlas V rocket. Included in the Cygnus shipment are payloads that will study fires in space, the effect of lighting on sleep and daily circadian rhythms, collection of health-related data, and a new way to measure neutrons. Meanwhile, a Japanese cargo ship's expected to arrive on station in December. It'll be delivering new lithium-ion batteries designed to replace the nickel-hydrogen batteries currently used to store electricity generated by the space station's solar arrays. The Expedition 49 and 50 crew members are also scheduled to receive SpaceX's 10th Dragon cargo supply ship, that's if they can find a rocket to launch it following the Falcon 9 disaster, and two Russian Progress cargo ships, each carrying several tons of food, fuel, supplies and research equipment. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for SpaceTime with Stuart Gary.
SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine. This month, looking at whether the next generation of supercomputers will be able to handle the mega streams of data expected from the next generation of giant telescopes like the Square Kilometre Array.